G'day, folks. Welcome to the first lecture from Lockie D. The first lecture from lockdown. Great to see you all here. Thank you so much for joining me live and online. To everyone who's out there on the internet. Hopefully, everything is going to be completely fine and fantastic with this lecture. Of course, it's always a little bit more complicated to run lectures when I'm at home rather than at work, particularly once everyone is at home. The rest of this course might take a slightly different, slightly different tone for folks who are in Canberra who are now stuck in lockdown. I know there's many folks who are, I'm not getting very much focused on my camera, there's many folks who are in Sydney, all around the rest of Australia who are already in lockdown. And I think my camera's working now. There were folks in Sydney and all around Australia who have already been in lockdown for a while, but particularly those in Canberra who suddenly had to go into lockdown, and particularly those in our ANU residential halls who have been having all kinds of problems getting food and getting in quarantine because one person in their building would be a secondary contact. These things are tricky to work out, and I hope you're all being very patient. As always, with all ANU courses, if you have unexpected circumstances beyond your control, particularly related to COVID-19, sickness, orders to quarantine or orders to isolate, that's something that you can use as evidence for special consideration. And of course, I'm always happy to hear from students who have issues telling me that they need extra time with assessment tasks. Hopefully they can give me that warning well before the assessment task is due. And if you have something which comes up on the day it's due, for instance, then applying for special consideration through the ANU is the way to do it. That means that I get an email with the evidence that you have for your situation, and an explanation of what the effect has been, and then we can work out something. But for an assessment task, generally that would be just giving you a little bit of a slight extension to make sure that you, for instance, if the day of your assessment you had to go into isolation and you couldn't get your stuff uploaded, then having an extra day or two to get that uploaded and squared away might make all the difference to you. So I'm always happy to consider those kinds of things. Please do use those systems. That's what they're there for. Of course, it's a time and a place where we're using these systems a lot more. Things like special consideration are happening a lot more these days just because the world is a crazy place right now. Okay, folks, I want to congratulate you all for completing and submitting assignment 1. Hooray! I should have a soundboard now I'm at home. But assignment 1 is done. You've got it all in. You did a great job. So far as I can see, I've looked at a few and thought, oh, that's a really cool name tag. I've just spent a few minutes this morning preparing for the marking process, taking a copy of all of the GitLab repositories that you've submitted last night, distributing those amongst the tutors, sending them out, and we will start working on the marking and getting those marks back to you, hopefully within 2 weeks. Basically, my hope is to get marks back to you by, maybe the start of week 6. So we'll mark it all next week, but we'll see how that goes. Unfortunately, I know that when people are stuck at home in lockdown, productivity tends to go in a negative direction, particularly mine, because I have a baby and a partner who is also working, also teaching, and has to be on Zoom, much as I have to be to do lectures. So it's a tricky environment. So if there's something going wrong and I don't answer an email, I'm really sorry. I try to get to urgent situations as quickly as I can. Sometimes that just doesn't happen until the late evening. But if you ask something on the forum, our tutors are there to help you as well. Okay, I'm just going to make myself small. The advantage of being at home is that I think I actually have a nicer setup for doing my lectures. So I've got a nicer green screen, nicer lighting, a nicer desk really, a nicer screen. I've got my synthesizers here so I can make some live techno for you. in the start, the intro and outro, and it's just all around. It's a slightly better way to be doing things. The super low res stream. Oh dear. Someone has a low res stream. My stream seems to be going all right. 6,000 KB per second. Whoops, someone set it to be the wrong. Twitch stream is good. Okay, they set their settings wrong. Okay. News of the day. You've now submitted assignment 1. Well done. Assignment 2 is now available. So I'm just going to navigate to that web page right now. Whoops, there you can see many Charleses. Navigate to this web page. This is assignment number 2. Your goal with this assignment is to create an interactive picture window. You can go and read this assignment and get across the spec, but the idea of this is that in your first assignment you made something which was static, an artistic static artwork within some limitations. In this one it's supposed to be looking out a window. I'm facing a window which you can't see, looking out a window and seeing things occurring out that window that change over time and that are interactive. So the previous sketch was focused on a static artwork. This one's an interactive artwork. The artist statement here is focused on this question. What are you trying to communicate with your interactive view through the window? And although in the first assignment we gave you your topic of communication, which was your own name and yourself, with this one you get to choose what that communication is. So you have to figure out some inspiration, figure out something you want to show, and create it, and then communicate that process to us through the artist statement. I'll go through this in some more detail later, but I just wanted to make you aware that it's now available. And particularly I want to make you aware of the deadline, which is 9 p.m. Monday, September 6th, first Monday of the teaching break. So this is an assignment which you will have to get started with now to make a good effort at it. Again, the assignments in this course are not hugely long assignments, except for the major project. We give you a number of assignments that are shorter so that you get more feedback from your tutors and get a number of chances to build up your skills with P5. So you should now have the skills to create a scene, conceptualize it, create it with shapes and the drawing tools, shapes, colors, text, images if you want, using the drawing tools within P5. And then your goal over the next 2 weeks is to work out how to make something which is changing in response to the user. So that's interactive. What's the spec here? Whoop. Requirements. It must be, oh, I don't think I have super obvious requirements, but it has to be a view through a window and it has to be interactive. They're the two main, specifications for this assignment. You'll also have to generate a PNG file for this one. You might be thinking, well, why do I have to do that if it's supposed to be interactive? Well, it will make more sense when we go to the next, maybe go to or as we go through, when you get your assignment ones back, you'll see that we are able to make a nice gallery with everyone's assignment in it. And if we have a PNG file there, then it works nicely as a little flat thumbnail. So in this assignment, you won't be marked on that image file. It's just something you add to your GitLab repo to help us to make a nice website so that everyone can see all the great work you do. Make a little gallery for your artworks, which I think is one of the funnest things in this course, when you get to see other people's great, insightful explorations of these assignments. Okay. The other news is that assignment 3 is also available. The assignments for this course are all ready, and given that our situation is changing a bit, I just wanted to make all of the assessment tasks available at this point in time, so you can feel free to use your time as you wish over this semester. Of course, the due dates occur throughout the semester. We kind of divide it into 4 parts. Assignment 1, Assignment 2, which is due at the start of the mid-semester break. Assignment 3 is due in week 9, that's kind of the third quarter. And then the major project is due at the end of week 12. Assignment 3 is to create a social media ad. This means you have to create images, you have to make it interactive, and you now have to make something which has a dynamic curve through time. I'll talk more about that later in the course. You're under no obligation to start assignment 3 now unless you really want to. What I do know is that in this course we have quite a number of advanced students. I know there's a lot of first years, a lot of folks who just started our Master of Computing or one of our bachelor's courses, programs I mean. But we also have a lot of folks who are taking this as an elective, and maybe they're a third year student. They might have a lot of other assignments on their plate, and I just wanted to say to you folks, feel free to do all the assignments now if you want to, and clear the deck so that you can work on your honors project or whatever you want to do. All of the assignment repos and instructions are there. But if that's not something you want to do, you don't have to do it. And of course, if you're a first year student or an earlier years student, I would advise you to wait before doing these assignments until I go through the lectures that relate to them, because there's some other details to fill in. The very important thing is that the major project is also out, and the theme for the major project will be dun, 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 timeless attraction. Timeless attraction. So the way we choose the theme for the assignment is that I talk to the tutors, I submit some ideas, they submit some ideas, and then we have a kind of little competition to work out which ideas are the ones we want to run with. Someone says the link to Assignments 2's repo is currently unavailable. I'll check that after this lecture, and it will be available by the end of the day. The theme for the major project is chosen as a kind of collective effort with the tutors. We submitted a lot of brainstormed ideas, chose a short list, did a little vote, and this one came up on top. So timeless attraction. I guess just thinking through this theme a little bit, it's kind of an idiom. It might mean, an attraction to an object or to another person, and timeless means that something isn't connected to any particular time or period. So I think when we say timeless attraction, it's really not exactly related to maybe the attraction you think of with romantic love, because that would be between two particular people, so it's not timeless, it's within a certain time, their lifetime. Timeless attraction is something more fundamental or transcends that idea a little bit. I guess that there's also different ways of reading these two words. In fact, you could start to interpret them as different words with spaces inserted between them. It could be time, space, less attraction, time, comma, less attraction, timeless, comma, attraction. There could be different ways to interpret this theme. One of the things which we think about when we're choosing a theme for the major project for this course is finding a theme that makes everyone spread out. So we haven't chosen a theme that is directly related to one sort of correct solution, because that's not the way that art works. Art works where many people all take the same input, normal experiences in the world, and come up with loads of different outputs, lots of different divergent ideas about how to interpret that. So I hope that you start thinking now about what your unique and divergent approach to this theme is. I want everyone to really dig a little bit deep and not just kind of go with the first thing that comes into their heads. Don't take the first idea and say, that's what I'm going to go with. Have a few ideas, sketch a few things out, and then come up with the bulk of your major project. After week 9, this course is mainly dedicated to doing a great major project. We give you a lot of help, a lot of scaffolding in terms of work in the labs and lectures to assist you with that. One thing I wanted to point out about the major project is that this, oops, I want that to be in a tab actually, so I don't lose my place. The major project is the assessment task where there are some different differences between students in Comp 1720, our undergraduate subject, and Comp 6720, which is our master's level subject. Of course, the expected outcomes from an undergraduate degree and a master's degree are different. There's a bit of an explanation of that on the major project page, but so what that means is that in some sense the master's students will be graded with a somewhat higher expectation in terms of how advanced they've engaged with the subject. But we also have some specific different requirements, which is that within the two statements which you'll write for your major project, an artist statement and an interaction statement, you explain how your artwork reflects recent developments in this topic. So that's one of the expectations for master's students within a master's degree, is that they're aware of how recent developments have informed the topic. And so that's a specific requirement with this assignment. Every master's student, every Comp 6720 student needs to explain these recent developments in both of their statements. We'll go into more detail about this later, but I just wanted to bring that up now so that everyone who's a Comp 6720 student is very aware that the standards are different between these two courses. There are actually two different courses running simultaneously. They have slightly different learning outcomes, and so the marking criteria are slightly different between them. Okay, that's my little spiel for admin. A recap of what we've been doing recently. What have we been doing lately? What have you learned so far in this first 4 weeks of Comp 1720? Well, you've learned to specify positions and colors with numbers. You've done a lot of drawing with the P5 library. We've focused a lot on that, using rect, ellipse, fill, stroke to make colors. We've looked at the color theory stuff, HSB and blend modes. We've looked at variables and declared some of our own variables. We've done a little bit of simple maths to manipulate numbers. And then in last week's lecture, we looked at conditionals, if statements, and Boolean expressions, and loops, while and for loops. So this is where we're at so far. And today I'm going to expand your kind of knowledge of the coding kind of vocabulary for this course. 2 more coding concepts, or 3 more really, 1 little one and 2 big ones. And that we're almost at the end of our kind of work, our oeuvre of coding concepts for this course, but here's the 3 more that we'll discuss. One's called scope of variables, and this is actually something you may have started to notice. You've seen this before a little bit, but a slightly different word for it. Then we'll discuss 2 new coding concepts. One is functions, and one is arrays. Now with functions, that's something which you have seen already. We've got 2 functions in our sketches. We've got setup and draw, but we'll be making our own functions from now. And then with arrays, it'll be a structure which allows us to collect a lot of things together, which is really handy when you want to make a more advanced sketch and organize your ideas in a more clean way within your sketch. Scope. What is scope? Well, what we've got here, this is story time with Charles mode. Story time with Charles, we have here a picture of a telescope. What does a telescope do? When you look through it, you take this big view of the world when you just don't have a telescope, and then you look through a telescope and you just look at one little part of it and you make that big, you focus on that. So it kind of cuts down our view of something. And that's exactly what scope kind of means within computing. Scope is a way of looking at parts of our code and making them sort of separate from each other, or considering how they're separate. In particular, we talk about how different parts of code can see each other. So if you're doing something in one bit of code, creating variables, that's the main one, then can your other bit of code see those variables? Are they aware of them, or are they somehow shielded from each other? Like different rooms in a house, you can't necessarily see what's happening in every room all throughout the house. So I'm just trying to get my gain exactly right on my microphone. It seems like a little tiny change is moving at too many dB at the moment. So which kind of bits of code can see each other? And at the moment, we haven't really discussed this, so maybe your assumption is that every bit of code can see each other. All of your bits of code is like being in an open warehouse where you can see everybody. But now we'll start to put up those walls, or there were walls that were already there. You'll understand why bits of code can't see each other. So the issue is that sometimes you may have run into a problem where you get a missing variable error in P5. You might have explored that if you've been looking at the console. It might be you've gotten that error, but you could actually see in your code that there is a variable there. And if that's the case, you might have a scope problem. So maybe the bit of code that's trying to use that variable doesn't actually know about the bit of code where you declared it and set it. So at a top level, we've got a kind of something called global scope, and that's like the scope for everything in your code. And if you define a variable in the global scope, that means you've defined it outside of your setup and draw functions. That variable is still defined and declared and defined, but it is actually visible to every one of those functions. So here's a variable, let x equals 200, and it should be visible to any code inside these functions. So x is at the global level. Now, on the other hand, in this example, x has been declared inside of a function within setup, and then it's used inside draw. So let's see what happens in this example. I'm just going to do a demo. Open my, whoops. Open up my sketch. Oops. So I'm just going to cut what I've got here and put in something new. So creating a canvas, I'll make it my whole window width and window height. Make it a bit bigger so everyone at home can see. You can see from the very back row. So made my canvas, created my variable x, and then I want to draw an ellipse using x. So it should be a 200 by 200 circle with its center at 200, 200 on the canvas. So if I save this, I'm not seeing any circles. And the question is why? Well, the answer is that this bit of code can't see this variable. If I move the variable into here, let's find out what happens here. Now I get my circle. So this bit of code can see this variable because it's within the scope of this function. Now, the thing that kind of defines different scopes within JavaScript would be these little guys, the little curly parentheses. So that's the little curly parentheses are making this bit of code a block, and that block is the bit of code, that block is attached to this function draw. So within that block, x will exist as 200, and outside of that block, it will not. If I put it here, this block can see anything which is sort of above it, but it can't see into the next room. It can't see into this other function block, which would have its own scope. So let x, even though let x is on and outside of this function, it can be seen by that command, ellipse. So I still get my ellipse. Now just to drill down on this a little bit more, if I put let x equals 200 back inside setup and it disappears, one question I have is, well, this seems dangerous because I've done something wrong. My code doesn't work. Even if I add other stuff, will it work? I don't think it's gonna work at all. I can write another ellipse, and that's not going to get drawn at all. So we're in a real problem now. My code's broken, and I don't know why. The way to find out what's going wrong with your code is to use what's called the console, the JavaScript console. So if I go into the menu, oh, where's my developer menu? Web developer tools. I get the console. It says here in very small writing. Oops, I'm going to turn myself to the left side so you can see it. Whoops, where's my thing? LHS small. Really hard to see that. Oh, I can make it bigger. Uncaught, reference error. Well, that's a great error. X is not defined. Well, that's the problem. This variable X is supposed to be containing a number, but it's not. We haven't set it yet. And when I put X over here, it ends up defined and all my code works fine. This one works and this one also works. You can see here I've also got some other little exclamation marks. There's a bit of a convention with errors that if something is yellow, it's like a warning in computing, and generally warnings are not a showstopper within this course. There might be some stuff in P5 which does generate a warning. It's not generating an error, so that means it hasn't broken your code. Other computer science courses, you might have to sweat the details and fix every error. Someone says, I write x, let x equal rand number. Let x equals random. I don't know what rand is going to do. Is that a real function? Whoops. We have another problem. We got two problems now. Someone says that it doesn't work with this particular kind of construction. And I agree it doesn't work. That's because you're trying to use a P5 function, random, outside of P5's kind of official functions set up. So what we would have to do here is say, let x, just declare it there if you wanted to make it random. Then we change it here, random 1000. So now we're within P5's world inside the setup function, and we can address it. So all of this stuff, all these errors, these are things that have to be handled. They're stopping this sketch from running. What you need to remember is that when you get errors in your sketch, it's generally not that your computer hates you. It's not that an evil spirit has taken over your computer. It's not that you've done something terribly, terribly wrong. It's usually that you've just put a line of code in the wrong place. The trick is to know which line of code it is and which is the correct place to put it. So that's where we can use these things like the console to help get some more useful information. So now I get my randomized ellipse, as the person within the chat was suggesting. Another question, does this work inside the P5.js web editor? I just want to show you that. So here's the same idea. I'll just run it. Reference error X isn't defined. So the web editor, when I use the web editor in lectures, it does give me these errors, and helpfully you don't even need to have the console in your browser open. And doubly helpfully is that it's giving you some sort of special information. If P5 says there's an error due to X not being defined in the current scope, there's that word scope on line 9. There's a line. It's giving you a lot more information here. If you've defined it in your code, you should check its scope spelling and letter casing. JavaScript is case sensitive. And then there's some helpful links to learn about this stuff. Data variable scope, you could read that later if you wanted to. This also is in the main console. So there's the main console, reference error, X is not defined. Same issue. So, if something's not working in your code, check the console. The way to do that varies by browser, but I just happen to know in Firefox on Mac or Windows or Linux, if you press Control-Shift-K, you get the console displayed on the screen. Anyone who is developing websites is intimately familiar with the console because it helps you track down all kinds of issues with the styles and positioning of things in your website. So it's a good thing to learn how to use, just as a general skill with web development and computing. Okay, there was the solution. It's in the slides if you forget what it's supposed to be. This works because x is in the draw function scope. Scoping tips. So scoping can cause a bit of frustration, but it kind of is a good thing because when you do separate your code a bit, have these isolated rooms within your code, you make clearer code and it tends to be more robust. And by robust, I mean some things in your code might use the same name, right? You might have a lot of for loops within different parts of your code, and they might all use the variable I as their looping variable. It's very common to use I as a looping variable in a for loop. So if you only have one variable called I at the global scope, then your for loops are going to overwrite each other's variables, and that could cause lots of errors. So using scope is very handy because things are isolated and names can be reused in different parts of your program without having to worry about them overwriting each other. And finally, the brackets matter. So this is the brackets define your scopes in JavaScript and many other languages. Okay, concepts 2 of 3 for today's lecture. Functions. Functions, finally, functions. A little bit of a high-level definition of functions. A function, the act of executing or performing any duty, office, or calling. Okay, that's a sort of a function as in a purpose, or the function of a role, or the function of an office, the function of an object. Function, a sequence of program instructions that perform a specific task. That's the function which we're looking at within programming. But it's sort of related, isn't it? Because this second part, this specific task thing from the second definition, a sequence of program instructions that perform a specific task, is related to this kind of calling duty or office. That's the specific task within the first meaning of function. So the specific task is the meaning, the task of this person, and the specific task in programming is the task for a chunk of code. What do functions look like? Well, you've already seen a lot, and we've kind of discussed them. Early in the course, I would tend to call them commands, because I like to think of these as giving a command to P5, draw a rectangle, change the fill color, change the stroke color, color in the background. But in fact, they're functions. All of those things, rect, ellipse, fill, stroke, background, color mode, all of these things are, in fact, a sequence of program instructions that perform a specific task. So there's two parts of a function that I want to talk about. The first part is the name. So in this case, it's rect in this example. So that specifies what these program instructions are supposed to do, or just to give a description of them. And the second part are the parameters. So they tell these instructions how to do it, where to draw the rectangle and how big. So together, these allow us to tell computers to do a specific thing and to repeat it with slight differences each time. So, we've made great use of these things so far in the course for the kind of basic drawing tasks or setup tasks. What color am I using? What's the background supposed to be? What shape am I drawing in P5? But now you're going to make your own functions as well as use P5's functions that come with it. Here's another meaning of function. There's a bunch of folks enjoying an adult beverage in a social situation, which is currently banned. No social situations allowed. So we say with functions, I tend to say that I've called a function. And this sort of relates to the first specific definition of function, which is like someone's duty. So I say I call a function because I'm telling that bit of code to do its job, or I'm calling the staff at a restaurant to come and give me an adult beverage. So we're telling these bits of code to do their job. How many jobs should a function have? That's a good question. there's a bit of a computer science convention that it's a good idea for a function to only have one job. So you split up your program into lots of specific jobs, and you define some functions to do these individual jobs, individual tasks. The you had one job principle is important for functions. So you had one job, it was to draw this rectangle and do it at a certain x and y location with a certain width and height. That's the one job of rect. Rect doesn't change colors, rect doesn't fill in the background. It's part of the way that programming systems are designed, is that all of the roles of different functions have to be designed, and we tend to make sure that they don't overlap or that they're just doing one thing and one thing well. Here's a talking exercise. We won't do the talking, but quick quiz. If you've got a function from the P5 library, how do you find out what the parameters mean? The answer, of course, is check the reference. We've done that many times so far, but the more you read the reference, the more you will learn about how P5 works and what the different things are that you can do. Here's where things get interesting. Writing your own functions. Well, in fact, you've been writing your own functions all along. You've got the setup function, the draw function, and all the other P5 functions, but in fact, the setup function and draw function, you've been defining what those functions do. They were kind of already given to you within your sketches as part of the template. But the way that P5 works is that there's a lot of code there in the background which is expecting to see in the sketch.js file a function called setup, which it's going to call and run once at the start, and then a function called draw, which is going to call and run many times for each frame of your sketch. So you've been using these functions all along and using the functions you don't have to define, like ellipse. But here's how you write your own function. Here's one called polka dot. So the way to write a function is that you just tell P5 function. That means I'm going to start writing a function now. And after you've told it function, you can then type the name of your function. In this case, that name is polka dot. And then you have to tell P5 what parameters to expect. And you don't need to give it a lot of information. Basically, in the first instance, all you need to tell P5 is how many parameters it's supposed to be dealing with. So in this case, we've got two parameters, x, y. Two parameters there. So what is this little function polka dot going to do? Well, it's going to change the fill color to red, and then it's going to draw an ellipse, 20 by 20 ellipse at this location, x and y, x, y. So this function is not particularly useful, it just makes a red circle, but it's not stupid either. It's a way of combining two little things into one line of code, which might be you might have a good reason to do that, to break up your code a little bit. Another good thing about functions is that when you make a function, you're taking some lines of code and you're giving them a name. And that really helps someone like me who has to read your code later, because then I kind of know what your code is supposed to do just by the name that you've given it. So if this was given that this is called polka dot, I expect it's going to draw a polka dot, which is exactly what it does. So that's a really helpful thing for others reading your code, particularly examiners who look at your code. It's really helpful for them to be able to see functions that specify what different bits of code are supposed to do. I want to make one. Let's do a demo. I'm going to start my demo for the day, which is a bit of a more involved one with functions. And I'm not going to make a function called polka dot. I want to make one that's going to make a kind of bug, draw a bug. Okay, so I've typed in draw bug for my function. I'm going to just take that x and y location, I think, x, y, and I'm going to have another parameter called b. Now in this function, I actually would like to make longer names for those parameters so that it's even more obvious what I'm trying to do. So it's going to be x location, y location, and brightness, 3 parameters for my function. And it's going to change the fill to be brightness, brightness, and 0. So you can see I can now use these parameters as a variable within my function. They've already been defined by whoever is calling this function. They'll put a number into that spot, and that number will be referred to by this variable within my function. And then I'm going to draw an ellipse. And the ellipse is going to be at that location, y location. And it's going to be a small circle. So I don't need to use my parameters for everything. I can use some numbers as well. Cool, there's my function. 2 things. It's going to change color and make a location. Someone said they wrote their own functions in assignment 1. That's fine. I know that to some folks it might seem like they really want to jump ahead and use these programming concepts in the early assignments. There are other folks within this class who are really sweating right now because they feel like I'm moving really fast through different programming concepts. So we have a really broad range of folks in 1720, 6720, and I have to present my lectures in a way that supports everyone who's totally new to programming and is also perhaps not too boring for those who are racing ahead, reading the textbook, reading the references really deeply, and learning a lot early on. Now it's time to use my function. I'm actually not going to use the draw function, or the draw area. I'll just use the setup area. I'm going to make a bug, draw a bug, and it's going to be at 100, 100. And the brightness is going to be 175 out of 255. I might make a dark background. Okay, let's try it. I've got my bug. It's a little yellow glowfly kind of thing. I can move it around, change this number, 250, 300, and make it brighter. And put it there. I might make 2 now. So this is where I can make reusable code. So I've got 2 little bugs. Make another one. More a dim one down there. So it's got a dim bug in that area and some brighter bugs up here. So maybe I want to introduce a bit of variation to these bugs within my function. I want them to be slightly different sizes. Maybe some of them are closer, some of them are further away. Now this is where things get a bit more fun because I can change things once within my draw bug function and it will be reflected every time I've called it. So this is where it's really useful to have a function in your code. Someone says they're the one sweating. Yeah, that's okay to be the one sweating. There's definitely tons of folks who are totally new to programming and they came in here thinking, this is great, I can learn some programming and I can be really creative at the same time. And that's the one thing which I really want to do in this course is support those folks. Everyone who, if you already know a lot about code, basically you're going to be fine. You can get through these assignments, put in the work, make something artistic, make sure you pay attention to the artistic side in the lectures. But when someone doesn't understand even what the words mean in the code, they can get feel very depressed about the course contents. So we do a lot of work to try to support them. What I have to say is that those folks who are sweating, The first 6 weeks of this course are the marathon, the sprint, I mean, and then the second 6 weeks of the marathon. So the first 6 weeks, you have to run really fast through a lot of coding concepts. And then in the second 6 weeks, we just pack those in and support them. So even if you don't quite understand it all in the first 6 weeks before the break, you've got the break to think about it, read the textbook a bit and understand them all better. And then you'll be able to have a really good crack at the major project after that. Okay, what was I saying? I can change something once in the function. Maybe I want the bugs to be bigger, and it will affect all 3 little dots. That's cool. Maybe I want to do something even a little bit trickier. I'm going to add in a bit of randomness. We talked about randomness and variation. I suppose I should say variation, not randomness, even though I use the random function. So I'm going to make it so that these bugs are a slightly different size and slightly different shape. They'll be not exactly a circle, but a kind of ellipse sometimes. And each one will be different because each time I call the function, it runs this code a separate time. So I call it that time, it runs it. Call it this time, it runs it again with the new parameters plugged into these variable names. Third time, runs it again with the new parameter numbers. Let's see what happens. So every time I do it, you can see every time I click play, it's running it again, and they're all kind of changing shape a little bit. Okay, now one more trick before I stop with this part of the example. I'm going to put them in a random location. Random width, I'm just going to do it with 1. And I'm going to make a random number between 100 and 255. Maybe. Okay. So I get one of my bugs is now moving around the screen. That's great. Now I want to delete these other bugs. I'm just going to copy this line of code maybe 4 or 5 times, 5 different bugs. And they're all going in a different location now. What about 10 bugs? 1, 2, 3, 4, 5. So now we're really having fun making bugs. Now we're having fun making bugs. My code's become a little bit messy though, because I've called this function a number of times. And I can combine this function with what we learned last week, the loops, and that might actually get us a slightly more neat setup function here. Someone's asked me a question I don't know the answer to. This always happens with JavaScript. JavaScript I find really confusing as a language. It's got a lot of strange history. It works strangely with variables, and I'm still learning about it as we go through it. I don't use JavaScript that much outside of this course. So I would say try and see. Tell us the results. Yeah, someone says I'm not alone there. Yeah, it's a very confusing language. It's well known to be confusing. There are efforts to make it make more sense, but it's a long road. Okay, I'm going to do what I said I'd do. I'm going to combine a loop with a function. So I'm going to say let numbugs equal 100. Define a new variable. And then I'm going to use a for loop. I showed you how to use for loops last week. For loops has to have this thing. You've got to make the looping variable, let I equal 0. Then we work out our test, I less than numbugs. And then our increment, I equals I plus 1. Okay, and then I've got a block of code. And I'm going to just take one of these draw bugs and put it in my loop. And this is now pretty great. I can now make 100 bugs without having to copy down 100, 100 lines. They've just done an experiment, the person in the chat. Well done. It does not. And I'm going to say the more you know. Now I've got 100 bugs. This is fantastic. I can really exploit the power of loops and functions with this kind of strategy, right? I've got a little bit of code, only 2 lines of drawing code. I've got a little bit of variation within this function, and then I've got a little bit of iteration, that's what we call it when we loop, to run a function multiple times. Every time it runs that function, we get put in a new location, a new x and y value. I put in a value, a number that I'm going to call brightness, which I'm using to create the color. And I'm putting in, then I draw that ellipse somewhere on the screen. I can make this bigger. I can make 1,000 bugs. I can make 10,000 bugs. It takes a little bit of time to draw that many bugs. So about 100,000 bugs. So I've got the loading sign there. Sometimes with P5, if you do something that's too hard, it takes a long time to do it. So if you have to run a function 100,000 times, maybe it starts to actually take a significant amount of time to do it. You can see that my bugs have a little stroke going on there. I don't necessarily want that stroke, so I might get rid of it. I only have to do it in one place. I can just run it inside my function, so that whenever I run that draw bug function, a bug will never be drawn with a stroke. I'll take this back from 100,000. That was a little bit too many bugs. Now we've got some good bugs. I really like those bugs now. They're looking like they're nice, like they're got a nice place in the world. Cool. All right, I'm going to work on this code a little bit more as we go through the lecture. We'll get to something in the end. But we've got a few more things to work through. Just take a sip. Sometimes you will want to make a function which returns a value or gives back a value. So you want to put in some parameters and you want to get something back from it. We can do that with a statement called return, which you will typically put at the end of the function, returning a value. Now there's a lot of, in this particular example, this function is going to be called double, and it's going to just take a parameter and multiply it by 2. So it's a very boring function, but we could use that if you wanted to multiply things by 2. Just more broadly within computing, in most computing subjects, this kind of pattern of work, making functions that return a value, is very important. It's the main thing you do in that subject, is make functions that return things. But in this subject, we tend to make functions that take an action. For instance, they draw on something on the screen, and the activity that they're taking is more important than what they return to you. So we tend not to use this one too much. I know some folks will want it. That's why we explain how to do it, and I've got the slide here. So if you're confused about how to return values from functions, ask, but in general, we will not need to do that. Someone says, why should we put in setup rather than draw? Well, you tell me, what do you think will happen if I take this code, and I put it into draw rather than setup? What do you think will happen? Let's try it. Whoa, it's just drawing bugs on top of bugs. I'll put in that background in here. Yeah, they'll be moving around, but it's more like they won't exactly move. They'll just sort of jump all over all over the place, which is not exactly what I want them to do. We'll talk about this a bit more later, a way of controlling that using something else, the third topic for the lecture. But the reason I put it in the setup script area was to use the flow of my P5 sketch, because I know that the setup function is only going to run once. I know that the draw function is going to be running lots of times. I could make the same effect, the same output, by using the no loop command, no loop function, which stops draw running over and over again. So now it just runs it once. That's why I did it. Okay. There's a few other special functions in P5. You've seen this one, key pressed. So you'll look at these in your labs in more detail, but the key pressed function runs whenever someone pushes a button on the keyboard. So you used that when you had to take the screenshot of your name tag, right? Key pressed equals a space. It was, if the detected it was a space, it would save the background, save your sketch as a PNG image. There's another one called mouse pressed, which is handy. Whenever the mouse is pressed, it's changing this little square. That's pretty good. So you can see that that's a function separate from the draw function. One thing I should say about these is that they're special from a flow perspective, because usually you expect your sketch to be running with, it runs setup, then it runs draw, 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 draw. But these ones break that expectation, because your code could be in the middle of your draw function, and if someone clicks the mouse, it's going to run mouse pressed. This lecture is going until I'm done. It's normally a Monday lecture, which would be 2 hours, yes. I'm not sure if mouse press runs within a draw function, if it would stop the draw function to do it, or if it would happen after. But it will certainly break that assumption that you're only running functions when you want to do them as the programmer, or getting that looped draw behavior, draw, 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 draw. So it will happen at any time someone presses a button on the mouse or presses a key. And read the reference to understand these ones more. You will get a lot of practice with key pressed and mouse pressed in your labs for the rest of the term, or particularly next week. We did talk about this a bit before, but there's some special functions like background where I haven't put any parameters between the brackets. And that doesn't mean in particular that this function doesn't take parameters. Sometimes functions work without parameters, but also with parameters, or with different numbers of parameters. There's different ways of specifying that within JavaScript, which we don't go into in this course. But just to know that there are some functions like that within the P5 library, and you've already seen that with background and the fill and stroke color functions. Okay, there's an example here, but it's something you really do in the lab, so you will work on that. Concept 3, arrays. What have I got in front of me in this little concept drawing? I have a shop full of lamps. Really, I've got a collection of lamps that are right in front of me. And some of these lamps are the same, right? But they're similar shapes, but they're different. I guess if you had like just 2 or 3 of these lamps, you could just refer to each one with a name, right? You might call one left lamp, middle lamp, right lamp, or big lamp, small lamp, orange lamp. You could just give them names and then you'd know what you were talking about. But if you run a lamp shop and you have so many lamps and you want to know which lamp you want, or keep track of all the lamps you've got, you're going to start to just have them in a big list, aren't you? Maybe a big Excel spreadsheet with each lamp listed. And in that case, maybe you're not giving each of these lamps an individual name. You might just give them a number or an index in your filing system or your spreadsheet. So you collect all of these lamps into a kind of structure or a list, and you're depersonalizing them a little bit. You're just giving them a reference rather than a specific name. And you might not know exactly where each one is, but you could get the information about it by searching under that reference. So back to P5, we've already met a few types: number, string and Boolean. We talked about those types already. There's some examples. Let my number equal 7, let my string equal tennis is fun, and let my Boolean equal true. So what we want to do is collect some of these things together into groups, just like the shopkeeper of this lamp store might collect the lamps together. So here's some examples of little collections of stuff. Array of numbers, 100, 24, -2, 18, 106. Array of strings, hello darkness, my old friend. Some arrays of booleans, true, false, true, true, false. And then some other stuff, an array of whatever, right? An array with many different kinds of stuff, numbers, booleans, a string, and an empty array, an array that doesn't have anything in it. So they're all arrays. That's what we're talking about for this third part of this lecture. So again, we talked about brackets a little bit earlier today. When you see these matching square brackets, that designates an array in JavaScript. Everything inside will be initialized as the elements of an array. There they are, those square brackets. Okay, a bit of vocab. The array is the whole collection. Each member of an array is called an element. That's how I refer to them. And the position in an array is called its index. And in computing for arrays, we tend to start at 0. The first element of the array is index 0. The second one's index 1. If I've got a big array with a number of elements in it, the number of elements is called its length. Some programming languages call it the size, but usually people know what you mean when you say length. And here's one. So, line of code. What are we doing? Let all the things. We're declaring a variable called all the things and initializing it to be an array with 3 elements. 0, 120, and 500. What is the length of this array? 3. What is the first element? 0. What's the second element? 120. What's element index 2? That'll be this one. Because the indexes of an array go like this. 0, 1, 2. So this one is the element 2, index 2 of the array, but it's the third element. So there's often a pattern in programming where people say they've got an array's length, maybe they've given it a variable name, array length, and they say array length minus 1. And that will give you the index of the last element in the array. Typical kind of thing to do. So arrays are variables. We're doing exactly the same thing as we have done with all our variables. We declared it and then we assigned the variable. Declare and initialized it. There's nothing magical or strange about this. It's just the same concept with a slightly new way of writing the thing which we want our variable to remember. Rather than a number, it's going to remember a whole variety of stuff inside that array. Why do we use them? Well, they're really, really useful in computing as well as JavaScript. You can do all these different things. You can find out how big they are. You can add, remove, or modify things. You can join them to other arrays. You can look for particular things. You can do a lot of stuff. You'd have to look through the JavaScript and the P5 references to find out more info about some of those things. We will talk about some today. But most useful, they're a way of collecting a whole lot of similar things together and using them later. And can you thinking back to the example I just showed you with the many bugs, 1,000 bugs on the screen, you can think about what I'm going to do in the demo a bit later, which is to start to collect information about those bugs in arrays rather than generating it from new every single time. Okay, here's an array, odd numbers with some stuff in it. This array doesn't actually have the odd numbers. It's got 1, 2, 3, 5, 7. They're not odd numbers. 2 is not an odd number. That's a bit strange. And now we've declared and initialized this array, I can access some of the numbers from it. So if I want to get out an odd number, I can take the variable name and then use square brackets after it to retrieve an element from that index. Odd number's 0, odd number's 1. I might try that in my sketch, hey? So I'll just get this line of code, whoops, put it into my P5 sketch. I'm going to use it in the draw function. Take that, chuck it in here. Okay, so I've been making my bugs. They can stay there. They'll probably get a bit overwritten by this procedure, but we'll see what happens. Defining and initializing an array, and then taking out a number. And I've taken out this number, the third index, so that's 0, index 1, index 2, and index 3 is 5. Now what if I just want to know what that is? With arrays, you start to really want to kind of view variables, because it's not always clear what you've gotten out of an array, because there's a whole lot of stuff in it. So I'm going to introduce you to something which we haven't done before in JavaScript, called print. So if I say print odd numbers 3, there it goes. It's printing out in the console here. And if I look in the main console, whoops, there's my 5. It's being printed a lot of times. Actually, I've got a little counter here counting up to 300. Someone's saying use console.log. Well, luckily we get this print function. I think it probably is a P5 thing. The print function puts something in the console so you can see it. I don't know if it's P5 or new JavaScript. I use print. If I did this all within the setup function, it will only happen once. So I might do that now so I don't fill up my console with a lot of extra numbers. So I can see that odd numbers 3 is 5. I'm just going to take one number, add odd number, one number I'll call it, one number, so I've made an array, taken a number out of it, or just looked at what that number is. I print what it is and then use it for the background. So it's just showing me that it's 1. So this is not a very useful sketch, but it's a useful pattern of using arrays, getting something out of it, looking at what it is with print, in case you don't know, and then using it somewhere in your sketch. Okay, I'll just stop that one. I mentioned this before, that all arrays start at a index of 0, not 1, which can be a bit confusing when you're new to computing, but we call it 0 indexing. Very common in computing. So the first element of your array has to be called number 0. Now there's one other gotcha with arrays, which is that something like this can break your sketch. So I've called an array, I've got my odd numbers array, and I'm looking for the 40th element, the 40th index. And in fact, my array doesn't have 40 indexes, it only has 0, 1, 2, 3, 4. So this is going to break it. Let's see what happens when I put it into my sketch. Whoop. Object argument is not a valid color representation. Well, that's not going to work. This is a bit of a confusing issue because the fact that it's returning something, background is saying it's not a color. But really the issue is that the array doesn't have anything at 40. So I can see what it is. It's something called undefined. I think we might have mentioned that before undefined was like a variable that hasn't been defined. but it sort of still exists. So JavaScript is being rather nice here. It's not completely breaking the sketch to find this this index which is out of range. It's just returning undefined. Some programming languages will completely stop if you try to do something like that. It can be a big pain to deal with. Okay, where are we? Changing things in arrays. We can change arrays by putting things on the end or putting things at the front. And we can also modify the elements which we've already got in them. So here's how to put things on the end and the front. When you put something onto the end, you use the push command. Odd numbers .push 53 is going to add one extra element to it. And if you put it onto the front, you use the unshift command. That'll put -7 right at the front. The unshift is a weird name. It sort of relates to thinking about how logical operators work in computing, which is a very strange kind of reference to put in a beginner's language, but the concept is not is still useful. You want to put something at the front, you can use a command to do it. You can use it also take things off the end and take them off the front. So if you use the pop command, that'll take something off the end. It's going to drop the 53. And if you use the shift command, it'll drop it off the front. It's actually not gone if you pop it off the end. You can do something like let end equal, odd numbers dot pop, and that will take, in this case, it will take 7 off the end, and I'll print that. So I've taken 7 off the end of the array and printed it. I might print the array after that as well, so we can see what's going on. Odd numbers. My odd numbers array that shouldn't have a 2 in it. I might add a 9. So you actually have the odd numbers. 1, 3, 5, 7. That's my array after I've popped off the 9, which was stored in that new variable end. Here's a little table. You want to add something to the front, you use unshift. You want to add it to the back, you use pop. Push, I mean. You want to remove something from the front, you use shift, or remove it from the back, you use pop. That's there in the slides for your reference later. So modifying things in the array is very similar to accessing them. You use the index to say which element you want to modify, and you just assign it to 12 in this case. So this is just going to go through the indexes. That's going to be 0, 1, 2, 3, 4. So this is the 4th element, which will be changed to 12. And then after that, it ends up changed. Okay. You could have a think about this problem. I'm just going to sip my water. So in this little example, we've got an array, all the things, 0, 1, 20, 500, and then I'm going to use the push command. That's going to add it to the end, isn't it? So let's just, oh, I guess there's an issue here. If we can't see that code in the middle, our array might have been changed, so we actually don't really know what all the things is going to be if it's changed by this code. If that code wasn't there, pushing something on the end would just give us 4 elements, adding 50 on the end. So I guess that's the trick with that talk, I forgot. Okay, we talked about print. What about putting arrays in arrays? So we did say that you could put any type into array, and that actually includes arrays within arrays, which is where things start to get a bit wiggy if you've got too many arrays within arrays within arrays. I would say this is, it's not dangerous, but it's just something you really have to think about if you're going to do it. Let nested array, there's the first element is another array with 1 and 3. The next element's 2 and 4. So if you access element 0, that will give you another array, 1 and 3, this first one. And if you access nested array 0, 1, it's going to give you element 1, 3, and then it will look for element 1 within that, which is 3. So that gets you a number. So this is a way that you can represent maybe a 2D arrangement of values. That could be useful. You can have arrays within arrays within arrays if you want to. Arrays all the way down. It's all possible in computing. Looping over an array. This is where we can do something quite interesting. We can use the length of an array to help us with a for loop. This is a really common pattern. So if we've got our for loop, let I equal 0, we know that the length of that is defined by dot length, a property of arrays that you can access. That just gives us the length of this array. So we can say I less than the length of the array and I equals I plus 1. And this means that we don't have to necessarily remember the length of our array. We can just get it later from that array itself. Yeah, I'm going to move back to my bugs for a little bit. I'll do a bit more of a demo with them. But feel free to jump in with questions about this topic on the forum later. I know for anyone who's new to arrays, new to functions, new to scope, this is probably a wild lecture. We did a lot, but it's the last of our kind of multi-topic lectures. So you can read more about them in these links if you wish. Particularly Dan Schiffman's intro on arrays is fantastic. Okay, back to my bugs. Where was I? Get rid of that stuff about odd numbers. We don't need that. Cool, here's my bugs. Aren't they cool? Lots of bugs. Now, what I'd like to do is, rather than doing the drawing in setup, I want to do the drawing in draw. So I'm going to put that in here. We found out what happens with my bugs when I do this, which is that they jump all over the place, which in some ways can be pretty cool, but whoops, this is not right. There we go. In some ways it's pretty cool. Someone says wildest thing is that JS arrays can have different types in them. Mind blowing, yeah. Your mind will blow even more next week if you think that's weird. Okay, so I've got my for loop in the draw loop, for loop in the draw loop, and the elf on the shelf. I don't have numbugs because that was not a global variable. Whoops, reference error numbugs is not defined. Look after your scope, Charles. I just taught the students how to do this. Don't make the same mistake. I'll cut that out and put it up here. All right, whoa, no, bugs going crazy. Now I've got to stop this. I really want to stop my bugs from doing that. So I'm going to say, let bug x's. I put a little xs because that's sort of plural of x. Let bug y's. I'm going to make some more global variables, and those ones are going to be empty arrays. Cool. Using empty arrays. Now, using a for loop. For I equals, let I equals 0. I less numbugs. I equals I plus 1. So now I've got these empty arrays, and I'm going to fill those arrays up with some numbers for the locations of each bug, each of my 1,000 bugs. I'm going to use the push function, and I'm going to put a random width in. I need their brightnesses as well. Bug bees. equals empty array. Oops. Bug wise dot push random width, and bug bees dot push random width. What? That's not the number I want. That should be random height for the y's, and the b's should be a random number between like 50 and 255, right? Yeah, that's what we did before. Okay, so now I'm going to loop over all my bugs and add numbers to those arrays. And then just to check, I'm going to print out bug x's.length just to see how many bugs I've got x's for. I won't do the loop. Ooh, no. We'll save that for later. Uh-oh, num bus? No, num bugs. Spelling mistake. So I get my bugs once, and I've got 1,000 bugs in those lists. It should be the same for all of the others, right? We'll just check. Bug wise has 1,000 elements in it again, and bug brightnesses has, again, 1,000 elements. That's fantastic. Okay, now I'm going to loop my code, and we'll see what happens. Oh, what? They haven't changed anything. Well, that's because I haven't been accessing those numbers from the array. I've created an array with all the x's and y's, but haven't used them yet. So I'm going to get an x out of there, and I'm going to do it by selecting the ith element of the array, bug x's in square brackets I. So that gives me the ith index in that array, starting at 0, because I starts from 0 in this for loop. Lucky I had that I variable there to do this with. Same thing here, bug wise I, and bug bees I. Oops, need an extra parenthesis there. Okay, let's see what it looks like. Ooh. Now this is pretty cool. I've got my little glowing bugs. They're sort of wiggling and they're kind of slightly giving this slightly strange effect. That's very nice, isn't it? So I got to use the variable that I was using for my looping variable, and use it 3 times within that to select one item out of each of these 3 arrays. And if I want to change my number of bugs, I only have to change it in one place. I only want 100 bugs, it's too many bugs. Maybe not quite enough bugs, 300 bugs. Yeah, that's a bit better. Now, one thing I could do, and this is getting a bit wild, but I might like to sort of modify each bug a little bit, as well as kind of letting it sit there. I wonder how to do that. Change their brightness or something as we go. I might make another function, modify bug, and it's just going to take one variable, bug index. Maybe I'll choose a random, it'll be like rolling a dice. You choose a random number, and if something happens, we move the bug, and if it doesn't happen, we don't move it. So let dice equal random 100 if dice greater than 75, then we're going to change one of these bug indexes. I'm going to add to the bug location. Else, if dice greater than 50, we're going to subtract from the bug location. How about this? We'll do... I wonder if this is going to work. Else if dice is greater than 25, add to the bug y location. Else if, I just need else for the other case. So I'm going to have 4 cases. 25% of the time we'll add a bit to its x location, 25% of the time we'll add a bit to its y location, 25% of the time we'll subtract from x, 25% of the time we'll subtract from y. So I'll change that within the array. So bug x's, bug index equals bug x's bug index. Even a bit more randomness plus random 2. And that time will be minusing something. And then the y's, same thing. And the same thing with a minus sign. I wonder if this is going to work. When I do these live coding things, I sometimes haven't tried it. I certainly haven't tried this before. So I'm going to modify bug I as well. So after I draw each bug, I'll give it a chance to modify. Oh, they're moving. Well, that's pretty cool. They're going kind of around the screen. It'd be nice if I could do that to their brightness as well. I might just add, I'll do another roll of the dice. We'll roll the dice again after that, random 100. And then there can be 2 directions for that. If dice greater than 50, else, now this is fun. I think I'm getting the ultimate little glow bug sketch. Bug brightnesses equals bug brightnesses plus random 2. Minus random 2. So we can change their brightness over time. Some of them are kind of disappearing, some of them are getting brighter. They're probably not changing all that much because they've got an equal chance of getting brighter or darker. If I want them to have just only get brighter or mainly get brighter, I could change this so it's more likely. If dice greater than 25, they'll get brighter. So 25% of the time they'll get darker, 75% of the time they'll get brighter. So they're much more likely to get brighter over time now. And that seems to be what's happening. Opposite way, change it so that they're more likely to get darker. So I've got some variation in my sketch. I've got some arrays, I've got some functions, and I've got some iteration. Things are getting pretty cool now within what we can do within P5 with these different code concepts. Here's my even Steven chances. So they're unlikely to get super bright, unlikely to get super dark. You can see sometimes they're jumping off the screen. They do have the capacity to go off the screen and they'll maybe come back later. It's just a number in an array. It's not like they get destroyed when they fall off the screen. Obviously P5 doesn't draw them when they get too far off the screen. Or it thinks it's drawing them but they're not showing up. Well, that's pretty cool. I'm going to call this one Glowbugs. And I'm going to save that in my collection for the week. So you can have a look at it after this lecture if you want to. Folks, it has been a lovely to be with you this afternoon on this lovely week for Thursday. Next week I'll be back on Monday with the week 5 lecture for Monday. Hopefully I will also do a Thursday lecture next week as well, but we're all working out our schedules for how we're going to be teaching mainly from home. So enjoy the labs for the rest of this week, those who still have a lab to go. I'll see you folks on Monday with, I think, objects. Yeah. Thanks, folks. We'll have some techno now.